This inequality will break into two pieces. 6 is less than negative x plus 2. And so we'll subtract 2 from both sides. I'm going to do it in red. Subtract 2 from both sides. And you get 4 is less than negative x. To get rid of this negative sign, what I'm really doing is imagining that there's a negative 1 sitting in front of the x, and to get rid of it, therefore, I'm going to divide both sides by negative 1. But what I have to remember is that when I divide by negative 1, I've got to flip the sign. So now it's 4, negative 4, is greater than positive x. So then when I go to the number line, x is less than negative 4. Let's say that negative 4 is here, and so I have an open circle, and x is less than negative 4, so it's going that way. And so let's do the other part. It would be, let's do it in blue, negative x plus 2 is less than 9. We'll subtract 2 from both sides, so we get negative x is less than 7, but again, we'll treat it as though it says negative 1 times x is less than 7. So I'll divide by negative 1 on both sides, and so I get x is greater than negative 7. So let's go over to the number line. X is greater than negative 7. So let's say that this is negative, well, zoom in just a little bit. Let's say this is negative 5, negative 6, and negative 7. X is greater than negative 7 means an arrow going that way. So all the solutions to the inequality exist between those two open circles, right in this region here. And there are no solutions to the inequality outside of that region. So for example, a good solution to this inequality would be negative 5. That would work. But something like negative 8 would not be a solution to this inequality.